Hey folks, welcome to your new unit. 4.1 Introduction to Polynomials. Let's say this together because lots of people can't pronounce it. Polynomials. Not polynomials, that's a common one. Not polynomials, that's also a pretty common one. Polynomials. Polynomials. I hope that you guys actually chanted that. That would really make my cold math heart really melt. This is a pretty text-heavy set of notes, so I'll be doing a lot of reading, but I'll also be kind of drawing and highlighting things that are important as well. So in algebra, we use algebra tiles to help model integers, which are our numbers, positive and negative, no decimals or fractions, and variables. So this would be our letters X, Y, Q. And remember the X, Y, and Q, they are kind of like stand-ins for a whole bunch of different numbers. So it's like X can represent any number, really. With certain algebra tile sets, negatives and positives are different colors. In other sets, we just say negative for subtraction and positive for addition. But algebra tiles look like this. Our 1 is just a little square. Our X is a longer rectangle like this. And you'll notice that the length of an X squared is X. Okay. And the width of an X squared is X. X times X is going to be X squared. So whenever you see a big square, that's our X squareds. Our skinny rectangle, that's an X. And ones are represented by a very little square. So a polynomial is an expression of the sum of terms involving a variable. You're noticing that there's the sum, but there are also negatives. Just think about it as adding negative numbers. The expression negative 3m squared plus 4m minus 8 is an example of a polynomial with the variable. Let's see. I'm just going to highlight. I'm going to highlight the letter. Oh, there's no letter on that one. More about that later. The variable m. This polynomial has 3 terms. And let's highlight the different one. Now, you know that something is a term because it separates with a positive and a negative. Here is a term. Here is a term. And our last and final term will be 8. So let's just record what our 3 terms are here. We have negative 3m squared. The next term is positive 4m. And the last term is negative 8. And again, when you have a plus or minus, when an addition or subtraction happens between 2 numbers, that's what makes the difference between terms. So you have to notice that we include the sign in front of the number with each term. Terms are numbers and variables, or the product of numbers and variables. So if I were to look at this one right here, negative 3m squared, literally what I'm doing is I'm taking negative 1, and I'm multiplying it by 3, and I'm multiplying it by m, and I'm multiplying it by m. This takes way longer to write than this. So it's a way of combining things into shorter statements. The coefficient of the variable or the coefficients of the variable are the numbers and the sign. So the number in front of the variable. So for example, with negative 3m squared, we say that negative 3 is the coefficient. Negative 8 is a constant because it does not have a variable. Now that is kind of a grade 9 answer. If you want to have a little bit more of a sophisticated answer, we're saying that negative 8 actually does have a variable. It's just you can't see it, because I would say negative 8m to the power of 0. What? Why? Because anything to the power of 0 is 1. So we have negative 8 times 1, which is negative 8. The term with the greatest exponent determines the degree of the polynomial. This polynomial, okay, the polynomial that we're talking about right up here, this polynomial has a degree of 2 because it's the biggest. We can also classify a polynomial by the number of terms it has. Polynomials with 1, 2, or 3 terms have special names. Now, poly just means many, and nomials are terms, so it's literally many terms. So if we were to get a little bit more specific, a monomial has, think of a monocle, 1. So for example, 2x squared, or just 5. They just have one term. There's no separation of pluses or minus, there's just one. A binomial, think of a bicycle, has 2 terms. For example, 5x squared minus 3, or negative 3 plus 7x, because we have both 2 terms in that. So here's one term separated by a negative sign. Here's another term. This one is one term and another term. Okay, so each have 2. Now think of, what do you think 3 would be? Think of a tricycle. A trinomial. A trinomial has 3 terms. So for example, 2x squared minus 5 plus 7x. Here's one term. Here's another term. And here's another term. So 3. A polynomial is usually written in decreasing or descending order. Oh, don't want to write in highlighter, yikes. That is, the exponents of the variable decrease. The exponents of the variable decrease from left to right. So for example, we should really write the polynomial 3k minus 2k squared plus 7 as, we start with the highest degree, negative 2k squared. You're noticing that the sign in front matters. It travels along with it. Negative 2k squared plus 3k plus 7. An algebraic expression that contains a term with a variable in the denominator such as 3 divided by n, or the square root of a variable such as the square root of 2n, is not a polynomial. So what I want you folks to do is I want you to go to Math-IXL and do grade 9, V1 and V2. And finally, as a summary, polynomials are many-termed expressions. They have many characteristics like degree, coefficients, and can be named by the number terms one has. Polynomials can be modeled with algebra tiles.